What is up, everyone, and welcome to another Rust electrical tutorial. I'm Gneissish, and today we're talking about the oil rig alarm. So what is the oil rig alarm? The oil rig and large oil rig both have hackable crates that start an event, and when you start that hack in the 15-minute timer, the oil rig sends out a frequency that you can pick up on an RF receiver. Now that frequency for the oil rig is 4765, and the frequency for the large oil rig is 4768. Now, both of these frequencies are part of a set of frequencies that are blocked to use for broadcast by the player. So if you try and set 4765 into a broadcaster, you're going to get a message at the bottom left saying 4760 to 4790 are restricted, which means that players can't send out signals on these frequencies, which is great because that means that you can use them confidently, that you're not being fooled or whatever. So the point here is that I made three sort of stages of this: the beginner, intermediate, and pro. You could think of these as easy, medium, and hard. It's not so much that the beginner is a noob circuit, it's just the complexity and relative ease of using them. So let's just go ahead and get started. So the beginner or easiest way to do this is to use the pager. And the pager is great because you can just set it to the frequency you want. You'd set to 4765 or 4768. In this case, I have this demo broadcaster and button to so we can test the circuits and stuff. This is set to 1. So if I run this, the pager goes off, I get a page. So if this had been if it had been set to the right frequency of the rig you were monitoring, and someone started the hack, you would know that the hack had started, and you now have 15 minutes to prepare yourself to get over there and counter. You can also do this using the Rust Plus app. You can just run a line to the RF receiver, 2 volts, which is conveniently what the branch puts out. If you're not sure about this branch, how I'm doing these sort of branch power things, you can check out the How to Wire Like a Pro video. I'll leave the link above, and just watch the branch section specifically. And then the output of this receiver, you would then run over to the input on the back of the smart alarm. You could set that to be whatever message you'd like it to be. And when this is also set to 1 for demonstration purposes. And so if someone simulate that, the alarm goes off, you'd receive a message in Rust Plus on your app, and you would know that you now have 15 minutes to counter. So those two are the absolute easiest way to do it. If you're looking for something more in your base, an actual system that has an audible or visual alarm and a counter telling you how much time you have left, you're going to use the clock circuit. Now, the clock circuit consists of this branch here to this branch here, so a branch, a timer, a blocker, and a branch. I learned this from Rabbit. I know Malinook has talked about this, so credit goes to a ton of people for going over this. But this is a relatively simple version that's an incremental counter, meaning it's going to count up. So we'll go ahead and just set this up. So I'm going to start by daisy chaining this power block here. I'm going to run power out of the first branch. It's going to run to the power in on your second, and the power out of the second is going to run to the power in on your third. And so what I'm going to do is I'm going to run a power line to this blocker here. And so I'm just going to jumper that up from here. We'll set up the branch values in the end. And then that blocker is going to run to the input on the branch next to it. Now this branch here is going to power 2 things. The branch out is going to power these 2, so we'll run that one next. And that's just going to run from the branch out, and it's going to jumper all the way over to the blocker here, and then that blocker's output is going to run to the input on the branch next to it, just like that. And the power out of this branch is going to run to the input on the timer right here. And then this light part is optional. So if you want to use a light or a speaker or whatever, you could do it here just by sort of trunking it through this line into the block pass-through. So this output goes to the block pass-through. So what I'm going to do is I'm going to go ahead and use a light. So I'm going to just daisy chain that light into that circuit, and then the pass-through of that light is going to run down and into the block pass-through, just like that. And so you just have to account for that in the voltage, and we'll talk about that in a minute. The output of the branch here is going to run to the incremental counter input. You're going to run that over to this, and you're going to jumper that in to the incremental counter for this counter here. Now the counter itself, the target has to be set to 15, And that's because when this reaches 15, it'll pass a volt to this blocker and shut power off. Otherwise, this clock circuit is going to run indefinitely until either it runs out of power, or and this will hit 100 and stop. So you want this to stop at 15, which is the whole point. So what you're going to do is set that to 15, the target, set target to 15. The power out, and this will be part of the clock circuit. This is going to run to the toggle on of your timer, like so. And then the last thing we have to do is we got to power the timer, or the counter, excuse me, and we got to power this RF receiver to pick up our signal. And so that's what these two are for. You're going to leave these in their default configuration. So I'm just going to run from the output of this one. This is going to run to the input on our counter here, and then we can do the other one, the branch out of the other one. Again, watch that video if you're unsure why I'm doing this. That's going to run to the input on our RF receiver here. It's just like this. Now the output of that receiver, and this is how this particular design works. This is going to run to the reset, the clear counter, I should say, the clear input on the counter. And so then there's a reason for that. We're making use of the set target at 15, and the fact that this thing, when it receives a signal, is going to pop it back to 0, which will allow this to run. And we'll kind of go over that. So at that point, everything's set up, and then that last thing we got to do is set our branches. And so this branch down here, the primary branch, if you are using just no lights or anything, you would set this to 9. I used a light, which means I'm going to set this to 10. So from 9, you have to add whatever it is you want to use in this line here to account for it. This branch here is going to be set to 5, and it will always be 5 because it's going to run from it's going to power this blocker here and this branch here. So it's 1, 2, 3, 4, and 5. And you can see that the timer is already running because it's already receiving power. So what I'm going to do is I'm going to unhook this line right here. And this is a great way if you want to work on the circuit when it's doing this. This will stop that clock circuit from rotating all the way around. So once this comes back, there we go. Now it has power and it'll let me manipulate it. You could alternatively set this by jumpering it before you hooked it up and set it. Sometimes I do that, especially on the bigger one over there. But I'm going to set this, you would set this to 60 seconds because you want this to be a 1-minute timer that every time it loops around, it ticks this once. So you want this to be 60 seconds. I'm going to set this for purposes of demonstration to 1 second because I don't want to wait 15 minutes to show you this. So I'm going to set it to 1 second. You'll set it to 60 seconds. And what I'm going to do is I'm going to hook this back up. And I guess I'll just stay consistent and use a blue line. And I'm going to hook this back up. And there we go. So it's going to run. And what's happening is you can see that it's counting up. And so once it hits 15, it's going to stop because it's going to send out. Oh, it's not going to stop. I am wrong. I didn't hook that up. It'll stop once I hook this up. There we go. Okay, so it's above 15. So anything over 15, it's going to do that. So to reset this, obviously at 20, that's a problem. This is set to 2. That's set to 2. I'm going to run this as if it were the oil alarm or oil frequency going off, 4765 or 4768. And what that does is it resets it, which also allows this circuit to run. And this time it will stop at 15. There we go. And that's it. That's how you do this. And so the way you interpret this is that when someone hacks the crate and it sends out the signal, whichever rig you're monitoring, when it sends it out, it's going to reset this, which allows this to run. And so this will, of course, only tick up once a minute. And so what you'll know is how many minutes it's been running for since the crate started. And so I think there is a bit of a disparity of the countdown between I've noticed it on the other circuit that I don't think they're actually 1-to-1, the crate's timer and these timers, but it's close enough. And so what you'll know is how long it's been active for. And so then just some simple math, if it's 10 here, you'll know you have 5 minutes left until the crate opens, which gives you an idea of when you can counter. So it's self-actuating. Every time someone does it, you don't have to do anything. It's just going to reset itself to 15. It'll stop at 15, and then when it runs, it'll reset down and start counting up. And so that's it. That's all you got to do for that one. This next one is a little more complicated. It makes use of that circuit there on top, pretty much, and then a second clock circuit on the bottom, and I'll explain that. And so the idea here was, I thought, well, if we can do that, can't we make a decremental counter, so a counter that counts down instead of counts up, so you know literally how much time you have left, give or take, until that crate opens. And so, and not only can we have a decremental counter count down, which that's not that hard to do, but could we have a decremental counter that counts down, and once it finishes, it resets itself and is rearmed for the next time somebody takes whatever rig you are monitoring. And yes, you can, and this is how you can do it. And so to build this, you're going to need 1, 2, 3, 4, 5, 6, 7 branches. You're going to need 3 blockers, 4 timers, a splitter, obviously the counter, an optional button, and lights if you want. And so the way we're going to break this up is the top one is the decremental counter. It makes use of the clock circuit. You can see it right there. There's the clock circuit right there. And so this will be the decremental part of the circuit. This is what counts it down. And this is what resets it back up to 15 for the next time that somebody starts the crate once it respawns on the particular rig. And so these over here, this is all power distribution, and this is of course from the battery. And so yeah, let's just go ahead and start with power. And what I'm actually going to do first before I do anything is I'm actually just going to jump power to these timers, and I'm going to set the timers up before I wire them in, just because I just think it's easier. So I'm going to do that. So this first timer is going to be set to a whopping 841 seconds. And that is because 840 is 14 minutes. And yes, that's not 15 minutes. 900 would be 15 minutes. The extra second is for the circuit to give it time to register that needs to reset. So, but it's 14 minutes and 1 second. And I'll talk about why that is. And it relates to how the counters work. But in the end, it doesn't matter. So 841 for that one. And then we're going to set up this one. And I'm going to set this one to 60 seconds because I'm going to go ahead and do this in real time, 15 minutes. I'll just speed the footage up immensely to show you it run down. So 60 seconds for this second one. And then this one right below it is going to be set to 1 second because we want this thing to reset the circuit quickly. And then this final one is going to be set to 13 seconds. And that was experimentally discovered as I tried to design this thing to work. That's just the ideal time for this to count this up to 15 and stop. So 841, 60, 1 second, 13 seconds. Okay, so now we got all this set, we can start wiring this up. So I'm going to start with power, and I'm going to jump power out of the out of the branch out of our base's, battery branch. And then I'm going to daisy chain this branch into the second. Power out of that goes to power in of the second, and we are ready to start running wires. And so I'm going to start with the top decremental part of the circuit. And so I'm going to run from the branch out. I'm going to run that to the input on our timer here. And then the timer is going to just run directly into the input of this branch. This branch's power out is going to run directly into the input of this branch. And so this right here is your accessories output branch, is what you can run. I'm going to do 2 lights, and I'll explain that in a minute. It has 2 volts that are accounted for in what these will be set for. So you get 2 volts with the circuit as it is. If you want to increase those volts, you're going to have to do some manipulation, and we'll talk about that. So the second branch is going to, just like the other circuit on the intermediate, it's going to run these 2 here. And so we're going to run the branch out of that branch is going to run to the input on our blocker right here. This power out of this blocker is going to run to the power in on the branch next to it. And then the power out of this branch, just like the other one, this is the standard clock circuit, that's going to run to the input on our timer. And this time, this timer is going to run straight to the block pass-through with no lights, nothing in it. We don't need to do that this time because you have, you have that accessories branch over there. There we go. And just like the other clock circuit, the power out of this is going to run over to the toggle on of our timer, just like that. And then the difference, of course, this time it's a decremental counter, so we can do this to the decremental input, the decrement counter input. And so I'm going to run the branch out of that to the input for the decrement on the counter, just like that. And that sets up that whole line there. And so the last thing we're going to do is we're just going to do our branch settings so we can make sure those are done. And so starting down here, you're going to set this to 30. Now, this is assuming you don't change something here. So this is going to be set to 12. And then this one here, the second branch up here is going to be set to 5. And again, that's always 5. That's part of the clock circuit. It runs 1, 2, 3, 4, 5. And so that is it. If you this 30, 12 accounts for this 2 volts right here. So if you were to add, say you wanted more than 2 volts of stuff, of accessories, lights, whatever, you'd have to change this branch's output. Let's say you added 5 to make this 7. You would add 5 to here. This would become 17. This would become 35. So that's just a tip. So I'm going to go ahead and just hook up these lights just because we're here. And so you just run the power out into these like so. Let's see if I can get that. Where is it? Sometimes it's hard to find the, oh, I'm connected to it. Cool. Cool. All right. So, and we'll hook that into there. There we go. And so that's all we need there because those are 1 volt each. So that takes care of the decrement part of the circuit right there. You should have something just like that. Now for the next part, and this is the reset or incremental part of the circuit. This is what's going to count it back up to where we want it. I'm going to start over here just like normal, and we're going to do from the branch out here, which we might as well set this now. It's going to be set to 9, and it will always be set to 9. And we're going to run that over to the input on our timer, just like this. And then this output of this timer is going to run to the input on our branch right here. And this is just, and now we have the standard clock circuit, so we'll just do that as we normally would. The branch out of here is going to run over to the blocker like so. That blocker is going to run out and into the branch switch here. The power out of this branch is going to run to the power in on your timer. That timer's output is going to run straight to the block pass-through like normal. The output of this, the power out of this branch over here, is going to run to the toggle on of your timer here. And then this branch out is going to run to the increment counter on the counter. So we're going to run that out and over and up over to here like that. There we go. And we might as well, since we're here, we'll connect the output of the button to the clear. This is optional. It's just helpful if something happens and you stop the circuit and it's like halfway through, you can reset this so that it'll reset this to 15 where we want it. And again, this target this time has to be set to 15, or I'm sorry, excuse me, 1, because we're counting down. So we wanted to target something at the bottom. Ideally it'd be 0, but you can't set these to 0, and that's what raises that. It's this reason that this is set to 8:41, so 14 minutes, is because this won't actually send out a signal at 0. It's going to send out a signal when there's 1 minute left, but that's okay, and we'll talk about that when we actually run it. So that is that. So we got to make sure we have all our branches set right. So 9 there. This one will be set to 5 again, always 5. 1, 2, 3, 4, 5, and that's it. And so that is the decremental part of the circuit. The reset incremental part of the circuit, we set this to 8:41, 60, 1 second, and this was set to 13. And so now you're ready to go. So the last thing we're going to do is we're going to set up some power distribution here off of this splitter here. We need 2 volts, 2 volts, and 2 volts, 2 for this, 2 for this, and 2 for this. And so we're just going to run this directly into here. This will send 7 volts here so that we have 6 to disperse out. And I'll just run these in red. And so this will be 1 goes to the blocker here, 1 goes to the counter over here, right about there. That's good. And the final one goes to the RF receiver over there. So we'll run this over to here. Okay, and then to hook all these things we just powered up, the receiver this time, instead of going to the clearly, is going to run all the way over to the toggle on. That's how the system is activated on this particular build. And so we're going to run the output of that receiver over, jump it over, and we're going to run that right over to here. The output of our counter is going to run to the input, the block pass-through input on our blocker here. So we're going to put that right there. And then we're going to run the, what's left? The, oh yeah, the blocker here is going to run up into the toggle on of our timer, which is going to run. And when you hook this up, you're going to see how this works. It's going to count this up to 15. And then when it hits 15, it'll send a signal out and stop it. And there you go. And so now it's armed. And so the only thing we have left to do is set the frequency of our RF receiver here. It's set to 3 right now because we're going to just make sure that it starts the countdown. We won't wait the full 15 minutes. But then I'm actually going to start this countdown from the, we're going to start it, and I'll show you that how it coincides with the countdown on the crate. And so at this point, we're just going to make sure we have everything right. So this is 30, 12, 9, 5. If I don't go to a branch, it means it stays in its default configuration, and 5. And that is it. And so now what we can do is, if I start this just to test it, we'll just run this on channel 3. And there it goes. And so that is counting down from 15 minutes. And so what's going to happen is that this is going to get down to 1. And since that's the lowest set target you can do, it's going to reset this circuit and stop everything at technically 14 minutes. But there's about a 30-second time disparity between this and the actual countdown on the crate, which means that in the end, it'll be around 30 seconds difference, which doesn't really mean anything. Is that once this stops, there's still 30 seconds left or so on the crate. And so that's okay, because I mean, if you only have 30 seconds to get across the map to go counter them, I mean, you're probably hosed anyway. So I don't, the alternative here is to set this to 16 so that it does an actual full 15 minutes, but that would ironically put you 30 seconds over the crate. And so you could do, manipulations to make this really line up, and maybe I'll do a video about that in the future, but it's not really necessary. I think this is fine. When this thing resets, there's 30 seconds left on the crate, which I think is fine. And so you'll see it tick down to 13. So if I were to say stop this, if I come in here and unhook this and then hook this back up just to stop that timer, you'll see this is set at 13. You can reset this by hitting the reset button, and it's going to count it back up to 15 and arm it for the next time that it is detected. So this is great. This is a totally automatic system, and it counts down. So this is the difference between counting up, counting down, and also having an auto reset on the counting down. And so what you do here is you'd set this to, say, if it was oil rig 4765, and then as soon as someone hacked the crate, it would set this off. And so what I'm going to do is just set this to 3, and I'm going to run it and let it run all the way through. I've already recorded footage of the crate countdown, so I'm gonna start the crate countdown, or count this countdown, and I'll picture-in-picture the crate, and you can see the disparity by the time it gets to the end. So I'm gonna go ahead and just start this. There it goes. It has been activated, and you can see that the crate has started. And so we're just gonna wait, and through the power of editing, we'll speed this up, and we will reconvene when it's done. And there you go. You can see that once it reached the 1 second, counting down from then 59 and below, the system reset itself, and an approximately a 30-second or so disparity between this and the locked crate timer. And again, I think that's okay, because once this happens, you're at 30 seconds, so you should be long on your way before this ever gets down that far. I think maybe I'll do a video in the future where I can adjust this and manipulate this so that it is exactly 1-to-1 with the crate timer, but I think this is good for now. That is all I've got, folks. If you have any questions or comments, you can feel free to leave them below. You can get me in my Discord. See you later.